In this problem, we have sand falling from a conveyor belt onto a conical pile at a certain rate, 9 cubic feet per minute to be exact. We're told that the radius of the base is always equal to triple the height of the pile. And the question that we want to answer is, at what rate is the height of the pile changing when the radius of the base is 3 feet? And we're also given the formula for the volume of a cone. It's V equals 1/3 pi r squared h. So let's just start start by writing down what we're given. We're told that the sand is falling at a rate of 9 cubic feet per minute. That's the rate of change of volume with respect to time. So as the sand falls at that rate, that means that the conical pile, which it's creating, is growing. Its volume is changing at the same rate. So we're given that the rate of change of volume with respect to time, dv dt, is 9 cubic feet per minute. Something else that we're given, I'm just going to write this down over on the right, we'll come back to it in a minute, is the fact that the radius of the base is always equal to triple, 3 times, the height of the pile. So we'll use this in a little bit when we get a little bit further into the problem. What are we asked to find? Well, we're asked to find the rate at which the height of the pile is changing. That's dh dt. So find dh dt when the radius r is 3 feet. And of course, we're given the equation for the volume of a cone. It's V equals 1/3 pi r squared h. Now, here's where I'm going to use the fact that r is equal to 3 times h. I'm going to use it here in my volume equation. I'm going to replace r by 3h. Let's just call this pi over 3. So pi over 3 times 9 times h squared times h. 9 divided by 3 is 3. So this is 3 pi h cubed. That ends up being my volume formula. Notice that I do want the volume formula to be in terms of h more so than r, because if you go back and look at what we're given, and more importantly what we're finding, we're given dv dt, we want to find dh dt. The dependent variables showing up in the derivatives, the rates of change, are v and h. So you really want v to be in terms of h, or h to be in terms of v, depending how you look at it. Okay, so now we take the equation, v equals 3 pi h cubed. We differentiate both sides with respect to t, so dv dt equals, taking the derivative with respect to t, of 3 pi h cubed. Okay, well, this constant multiple pulls through the differential operator, bring the constant out in other words, and we're left with 3 pi times the derivative of h cubed with respect to t. Well, that's going to be 3h squared times dh dt, or 9 pi h squared dh dt. Okay, so on the left side I've got dv dt, on the right side I've got 9 pi h squared dh dt. Now I'm asked to find dh dt when r is 3 feet. So let's do that. First of all, dh dt is what I'm looking for. So I'm going to go ahead and solve the equation for dh dt. I'm going to divide both sides by 9 pi h squared, and I get dv dt over 9 pi h squared equals dh dt. And now I'm going to start plugging in the information that I'm given. So for dv dt, that's 9. And then in the denominator, I've got 9 times pi. Now I want to know what h is. Now remember, we're asked to find dh dt when r is equal to 3. Let's go back up here. This is the equation that relates r to h. We're asked to find, as I said, the rate of change of height, dh dt, when r is 3. I want to take that equation, go into that equation, replace r by 3, and then solve for h. And you can see that I get h is equal to 1. So when r is 3 feet, h is 1 feet. And remember, I need the h, right? Because this was given in my expression for dh dt. In the denominator, I've got h squared. So I replace the h by 1. Of course, when I square 1, I just get 1. So long story short, the 9's cancel. I get 1 over pi. Now you can approximate this using a calculator if you'd like. It doesn't really matter. I'm just going to leave it like this. The units, by the way, remember the units of volume are cubic feet. The units of length are feet. And this is dh dt. H is measured in feet. It's a length. So the units would be 1 over pi. The answer would be 1 over pi, and the units would be feet per time units per minute.